Imagine being on a plane and suddenly, no one is in control. This aircraft flew through the skies for 2 terrifying hours with no one at the helm. How did this happen, and how did it end? Today, we uncover the incredible story behind the flight that defied all odds. The disturbing story of Air Astana Flight 1388 began about a month before the accident, when the operator, Air Astana, flew the Embraer 190-100LR to a maintenance base in Portugal called Alverca do Ribatejo. A Portuguese maintenance firm, OGMA, Indústria Aeronáutica de Portugal, was contracted to perform the maintenance check. This isn't unusual. When airlines do not have their own maintenance organizations, they frequently contract with third-party providers. The aircraft was scheduled to undergo extensive maintenance. This included a standard C2 check, which the aircraft must undergo after a certain number of cycles or hours, as well as a couple of service bulletins. Now, aircraft manufacturers send service bulletins to airlines instructing them to upgrade their aircraft. In this case, they needed to upgrade some of the cable routings that led to the ailerons. They also had to completely replace the aileron cables from stainless steel to carbon steel. That meant that maintenance personnel would have to completely remove the old cables before installing the new ones. Maintenance was supposed to take about half a month, but the workers needed some help. When they attempted to replace the aileron cables, they found the instructions difficult to read and needed clarification. More graphic material is also needed to demonstrate how the cables should be connected. As a result, the work took slightly longer than expected. They needed to test the work after they finished it. You must do this after any heavy maintenance to ensure you haven't done anything incorrectly. However, when they powered up the aircraft, they received an ACUS message stating, "Flight controls, no dispatch." This is an ominous sign when you've been working with flight controls, and get this. So, the engineers and mechanics started troubleshooting the problem. They tested several systems, including the flight control modules, part of Embraer's computer system, and the actual physical connections. But despite all of these tests, it appears that no one checked what the ailerons were doing when the yoke was moved into the cockpit. Before we continue, you should understand how an aircraft moves along its roll axis. 2 distinct systems primarily control this. The ailerons, or rudders, are located on the outermost part of the wing. They tend to move upwards on the downward-facing wing and downwards on the opposite wing, causing the aircraft to roll. But there's another system: flight spoilers. When you tell the aircraft to turn one wing down, the spoilers appear on that wing, reducing lift and causing the aircraft to roll. These 2 systems collaborate to achieve the same goal, with one operating at lower speeds and the other at higher speeds. The Embraer 190 is similar to a hybrid aircraft, which will be important in this story. Some of the flight controls are fly-by-wire, meaning that what the pilots do in the cockpit is converted into an electronic signal sent to an activation unit via the rudder. The flight spoilers are fly-by-wire, but the ailerons are controlled by conventional wires that connect to the flight controls, so you have 2 systems that work together. As the maintenance dragged on, the pressure on the maintenance organization to complete the job increased, so they contacted Embraer for assistance with the flight control no dispatch issue. They eventually cleared the message by replacing some flight control modules in the guidance computer, and it did not return. This meant the aircraft was ready to be returned to the customer, who could fly it back to its home base. On October 11, 2018, the Air Astana Flight 1388 pilots reported to the airfield. The flight was scheduled to refuel from Portugal to Minsk, Batur fuel, then continue to Almaty, Kazakhstan. The crew planned for this flight was typical, and I say that because, in general, after extensive maintenance, most airlines have pilots specifically trained to perform acceptance flights. But Air Astana did not do it that way. It was a regular flight crew of 3 pilots. The captain was 40 years old and had accumulated 6,009 hours of total time. Together with him was a 32-year-old first officer with a total of 2,692 hours. The third pilot in the cockpit was the first officer, who had slightly more experience. He was 26 years old and had logged 3,514 hours. And as the story progresses, this third pilot's role will become increasingly important. On the flight, there were 3 passengers, all of whom worked for Air Astana, primarily in maintenance roles. The weather outside was terrible when the pilots and passengers arrived at the aircraft. In the heavy rain, visibility ranged from 2,000 to 3,000 meters. It was cloudy, essential, because we want relatively good weather when we accept flights after heavy maintenance, primarily if the flight controls have been maintained. This is because you want to remain in visual meteorological conditions in case something goes wrong, allowing you to make a visual return to the airport of departure easily. However, that was not the case on this particular day. The crew begins their pre-flight preparations, and they quickly realize there is a problem with the ventilation in one of the avionics bays. One of the hydraulic systems also runs at a low volume level. So they call the engineering team back and say, "We're not going to accept the aircraft like this." They get off the aircraft, the maintenance team works on these issues, and 2 hours later, the plane is finally ready for departure. When the crew returned, they resumed setting up the aircraft. Now that they had received no warnings, they started the aircraft and began taxiing for departure on runway 04. During the taxi-outs, the crew performed their pre-flight checks, including a check of the rudder surfaces. On the Embraer 190, you check your flight controls by moving the yoke around and verifying that the rudder surfaces move correctly on a screen. There appears to have been an oversight here because if the pilots had looked down on the screen, they would have noticed an extraordinary indication. As they moved the aileron to turn left, they should have seen it coming up on the left side. But in this case, it went down and came back up on the right side. However, the flight spoilers were moving as they should. Air Astana Flight 1338 took off from Alverca's runway 04 around 1330. The first 30 seconds appeared to have been fairly normal. However, when the pilot in command, who in this case was the captain, attempted to engage the autopilot, it did not engage. As he flew the aircraft manually, he realized he had almost no control over it. You can see why. As he tried to turn the aircraft, say, to the left, the aircraft would have wanted to turn to the right using the ailerons and to the left using the flight spoilers. This makes the aircraft completely unflyable. Within a minute, they made the first Mayday call to Alverca Tower. This coincided with the flight's first major upset, and there will be many more to come. What is about to happen to this flight crew and its passengers is one of the most terrifying things I've ever read from a flight data recorder. As they attempt to control the aircraft and issue a Mayday call to air traffic control, its speed drops from plus 20,000 to minus 16,000 feet per minute, with G loads ranging from plus 4.5 G to minus 0.5 G. Massive forces act on the airframe, and the aircraft turns completely inverted. I can only imagine how the pilots feel when dealing with an upset in the same way they were taught and learned in the simulator, and when they first started flying. The flight controls are doing the exact opposite and, at times, completely inexplicable things. Furthermore, they do not receive any indication of fault. They receive no warnings other than the ground proximity warning system, bank angle warnings, and everything else screaming at them, but nothing on their instrumentation explains why this is happening. They'll have to try to figure it out for themselves. Air traffic control recordings are being saved from this flight. And again, I'll link to VAS Aviation's excellent video in the description. Still, it's heartbreaking to hear because the crew's first few calls ask for radar vectors out to sea to ditch the aircraft and try to increase their chances of survival, but most importantly, to avoid third-party casualties. The radar screen shows the aircraft turning entirely incorrectly whenever air traffic control gives them a vector. It's not doing what they expect. This situation, in which the aircraft cycled through extreme climbs and descents, rolls, and G-loadings, lasted more than an hour. I get sick just looking at the graph depicting what these guys went through, and I can't imagine how it felt in the cockpit as this happened. But I want to emphasize here that these guys never stopped troubleshooting, which impressed me greatly. They never gave up, and they continued to try to figure out how to A, control the aircraft, aviate, and get the plane under control, because in between these extremes, they were able to level the plane off, which meant that they could sort of figure out what to do to keep the aircraft more or less level through trial and error. Not only that, but they were also very collaborative and communicative with one another. Do you remember how I said the third pilot, the guy in the jump seat, would be crucial to the outcome? Throughout these extreme maneuvers, he provides technical advice to the captain and demonstrates a thorough understanding of the aircraft. In addition, he acts as a relay between the cockpit and the passenger in the back, attempting to determine why the aircraft is doing this. After a while, they realize that the problem appears to be with the ailerons, and they start troubleshooting very early in the flight. Only about a minute after the first indication of flight control problems, the flight data recorder shows that the crew switches from customary to direct law. In the Embraer, in normal mode, the pilot's input goes through a flight control computer, a flight control module, which feels the aircraft's configuration and speed and modulates the outputs to the actual flight control surfaces. In contrast, in direct law, the input from the flight controls is directly translated through the flight control surfaces. The benefit here is that in direct law, when the pilots applied aileron input, there was a small deadband in which only the ailerons were activated, not the flight spoilers. Even though the ailerons were now moving in the opposite direction, it was still far superior to having opposite activation of ailerons and flight spoilers because the aircraft could not be controlled. So, in direct law, the crew eventually figured out that if they do teeny tiny aileron inputs when they turn right, the aircraft will bank to the left, but it will do so continuously. However, if you put less effort into it, you will retain control of the plane. So they figured it out after about an hour and 15 minutes. When they figured this out, they were intercepted by 2 Portuguese Air Force F-16 fighters. As a result, the crew faced new challenges. And I'll tell you all about it, and how this terrifying flight ended after receiving this message from my latest sponsor. I'm thrilled to have Manscaped as this video's sponsor. Manscaped is a high-quality grooming product provider for men, and they've recently released their latest trimmer, the Lawn Mower 4.0. Now, the Lawn Mower is an exact grooming tool. I use it to trim my beard, but because it has extremely sharp ceramic blades and skin-safe technology, you can also use it to cut other areas. The Lawn Mower is waterproof, so you can use it in the shower or rinse it. It also has an excellent LED light that illuminates the area you're trimming, which I find very useful. If you choose the Performance 4.0 package, you will receive the Weed Whacker nose and ear trimmer, ball toner, and ball deodorant for those unique places. If you think that sounds awesome or that I should get it for my partner, then use the link in the description below and the code MENTOR to save 20% off the original price. Your balls will thank you. After an hour and 15 minutes, the crew began to gain control of their aircraft. They've also realized that keeping the flaps at 1 gives them about 7 degrees of trailing edge flaps and 15 degrees of slats, giving them more maneuvering room. Extending the flaps when you know the aircraft will be subjected to these G-loadings is risky. However, it is preferable to have control of the plane rather than risk damaging it. The alternative is to lose complete control. They are now maneuvering and attempting to follow air traffic control radar vectors pointing southward because the weather was much better in the south of Portugal on this particular day. Remember that they left in terrible weather, which made it difficult for them to sort things out. It's becoming much easier now that they're in clearer weather, but the Portuguese air defense has sent up 2 F-16 fighters to intercept the crew and assist them with navigation. The problem is that as these 2 F-16s approach the aircraft, they forget to turn off their TCAS, so the crew is now sitting there with complete TCAS warnings. So you can hear on the air traffic control recording that they're asking them to turn off the TCAS. From this point forward, it is less about the crew wanting to ditch the aircraft and more about actually finding a suitable alternate location to attempt to land the plane. Initially, they considered diverting to Faro, in southern Portugal, where the weather is better. However, air traffic control advises them to go to an air defense base called Beja, and that's much closer. So the crew begins to descend towards Beja with the assistance of the fighter jet, and they decide to attempt a visual approach into runway 19 right, Beja's main runway. After that, the captain begins to aim for the runway. The flight readouts show that they're never really stabilized. They are constantly moving left to right along the center line. As they get closer, it becomes clear that he won't be able to stabilize the approach, so he'll have to fly around with this flight control condition. After the first round, the first officer is so physically exhausted from the ordeal that they've just been through that he can't continue. So the captain, who must be some Superman, swaps the first officer for the first officer sitting in the jump seat. So he jumps in, and they take a second visual approach. The same thing occurs. They become unstable near the end of the approach and must repeat the process. On the third approach, the crew is still unable to land the aircraft on the centerline runway 19 right, but when the aircraft begins to drift to the left, the captain realizes that they have runway 19 left, which is slightly narrower. He believes he will be able to land the aircraft on that runway, so he points to it, and nearly 2 hours after takeoff, the aircraft safely lands on runway 19 left in Beja. As soon as the aircraft comes to a complete stop, the fault message Flight Control No Dispatch appears on the EICAS display. This crew has managed to land this aircraft in Beja in one piece, thanks to their skills, grit, and excellent communication, which is an incredible accomplishment. There is just one injury. One of the passengers sprained his ankle slightly, and everyone felt queasy and exhausted due to their experience. Apart from that, they are all fine. In contrast, the aircraft is in poor condition. When the maintenance team examines it, they discover that nearly all flight control surfaces, flaps, and even the wings have been subjected to forces far beyond their design limits. Wrinkles appear on the skin and throughout the body. Once they've finished examining it, only the first third of the aircraft is undamaged, and the aircraft is a total loss. It needs to be scrapped. So why did this happen? After determining that the aircraft was severely damaged, the Air Accident Investigation Team began investigating how the maintenance was performed. They quickly discovered some serious flaws in how the Portuguese maintenance organization operated. They found organizational flaws, such as a lack of a just culture and confidence in reporting problems to higher levels. Also, there were some general flaws in how the work was completed and work orders were signed off. Furthermore, they discovered that Embraer needed to rewrite some of their maintenance manuals to clarify how to connect the aileron cable so that it did not cross, as was the case here. Air Astana also needed to devise an acceptance program in which pilots who were supposed to accept the aircraft after extensive maintenance received special training and were aware that weather restrictions were in place. The pilots were also blamed for failing to check the flight controls before takeoff properly. If they had, they could have prevented this from happening. Thanks to teamwork and skill, the crew safely landed despite the odds. Want more stories like this? Hit subscribe and check out this video on another flight with control issues. Stay curious.